Hello students, I hope you are fine and doing well in your studies. Student, today we are going to start our chapter relation function. And in this session, we will study some basic examples, definition of relation function. Okay students? Student, now let us start with the chapter itself. Students, here we are going to study chapter relation. In this chapter, we will study ordered pair, representation of ordered pair, and Cartesian product of the sets. Now students, what is the ordered pair? It is the main concept of this chapter. A pair of objects written in a particular order is called an ordered pair. What is the meaning of particular order? In this ordered pair, order is important. That's why the term particular is coming here. Let there is an ordered pair A, B. The position of A and B is important. We cannot interchange the position of A and B. A is called the first element of this ordered pair and B is called the second element of the ordered pair. It is not merely a bracket. It is an ordered pair. Means in this chapter, if somewhere it is written like this A, B, then please remind it is ordered pair of elements A and B where order is important. Understand students? Now students, what is the equality of two ordered pair? If two ordered pair, let A1, B1 and A2, B2 are said to be equal if first element of first ordered pair is equals to first element of the second ordered pair and second element of the first ordered pair is equals to second element of the second ordered pair. Then we can say A1, B1 ordered pair is equal to A2, B2 ordered pair. Let's see an example. If it is given that ordered pair x minus 2, 2y plus 1 is equal to ordered pair y minus 1, x plus 2, then find x, y. How we can find the value of x and y? Here, two ordered pair are equal and it will happen only when x minus 2 should be equal to y minus 1 and 2y plus 1 is equal to x plus 2. Now simplify it. X minus y equals to 1 and x minus 2y equals to minus 1. Now solve it simultaneously. Means x minus 2y equals to minus 1 here. Now subtract it. This plus, this is the plus sign, cancel out. Here y equals to 2. Now put the value of y in above equation. You can see x minus 2 equals to 1. The value of x is 3. Means find the value of xy. X equals to 3 and y equals to 2. Students, now we will study Cartesian product of sets. Cartesian product of two sets A and B is the set of all those ordered pair whose first coordinate is an element of A and second coordinate is an element of B. This set is denoted by A cross B and read as A cross B or product set of A and B. Symbolically, A cross B is equal to, it is the bracket or you can say representation of sets. Here is the ordered pair A, B such that A belongs to A and B belongs to B. Thus, A, B belongs to A cross B. Both implies A belongs to A and B belongs to B. What is the meaning? Means Cartesian product is a set of ordered pair. Means it contains ordered pair. Different ordered pair are listed here, such that first elements come from set A and second elements come from the set B. Now let's take an example. Let A is a set 1, 2, 3 and B is a set 3, 5. Then what will be the Cartesian product A cross B? According to the definition, it is the collection of ordered pair, such that first elements come from set A, means from the set A 1, and second element from the set B, it is 3, and so on, means 1, 5, then 2, 3, 2, 5, then 3, 3, and 3, 5. It is important to note that this 3 comes from the set A and this 3 belongs from the set B. Okay, this is the basic definition of Cartesian product of the two sets. There is some important notes. What is the meaning if A equals to 5? Means there is no element in set A, or you can say there is no element in set B. Then the element of A cross B will be 5, because in A cross B, first elements come from set A and second elements come from the set B. If any one of them have no element, then A cross B is 5. Got it? Now, A cross B is not equals to 5. Second point, if A cross B is not equals to 5, then it is necessary that A is not equals to 5 and B is not equals to 5. It is obvious case. If at least one of A and B is infinite set, it is a common sense, and other is non-empty set, then A cross B is also infinite, because if A has infinite elements, then for the all elements of A, there is an element in B. That's why A cross B is a set which also contain the infinite elements. Students, A cross A is also denoted by A square. One example is here. We have to find A cross A when A is given. Let write A here. It is 1, 2, 3. Now what is the A cross A? A cross A is the set of ordered pairs such that first element come from the set A and second also come from the set A. Means it is the 1, 1, 1, 2, 1, 3. Then 2, 1, 2, 2, 2, 3. Then 3, 1, 3, 2, 3, 3. This is A cross A. Next example. If G equals to this, H equals to this, then find G cross H. G cross H will be set of ordered pairs such that first elements come from G and second elements come from H. Then it will be 7, 5, 7, 4, 7, 2, 8, 5, 8, 4, 8, 2. And H cross G will be 5, 7, 5, 8, 4, 7, 4, 8, 2, 7, and 2, 8. Students, let's see one more example. If A equals to this, B equals to 4, 5 and C equals to 5, 6, then find A cross B union C. First of all, we have to find B union C. As we know, B union C will be 4, 5, 6. Now we have to find A cross B union C. It is the Cartesian product of set A and the set B union C. It is the ordered pair, set of ordered pairs such that first elements come from set A and second elements come from set B union C. Means it will be 2, 4, 2, 5, 2, 6, 3, 4, 3, 5, and 3, 6. This is the question number 1. Now question number 2, we have to find B intersection C. B intersection C will be 5. Now we have to find A cross B intersection C. Now it will be 2, 5, and 3, 5. Students, let's see one more example. If it is given that A cross B is equals to this set, then we have to find A and B. As we know, this is the collection of ordered pairs such that first elements come from set A and second from the set B. That's why set A contains A, B, because it is the first element and there are only two elements. Like this, set B will be collection of second elements of the ordered pair, means it will be x, y. Students, what is the Cartesian product of more than two sets? Let there are three sets A, B, C. Then the Cartesian product of the three sets will be set of triplets A, B, C, such that A belongs to set A, B belongs to set B, and C belongs to set C. Got it? And here it is mentioned that Cartesian product of n set. It is a collection of x1, x2, xn such that x1 belongs to A1, x2 from A2 and so on. Okay. Now student, one more thing. How we find the Cartesian product if sets are given like this. Okay. First of all, if you want to find the Cartesian product of A cross B cross C, then you can find either A cross B or B cross C first, means this side, or you can say this side. What will be the A cross B? It is 1, 4, 1, 5, 2, 4 and 2, 5. Now we want to do Cartesian product of three sets A cross B cross C. It will be equal to A cross B cross C, or you can say it will be equal to A cross B cross C. Here we are going to apply this system. Means now it is a one set and second set is C. Got it? 6, 8. Now the value of A cross B cross C will be first elements belongs to this ordered pair and second from this, means it is 1, 4, 6. Now 1, 4, 8, 1, 5, 6, 1, 5, 8, 2, 4, 6 and 2, 4, 8 and 2, 5, 6 and 2, 5, 8. This will be A cross B cross C. For the n product, or you can say product of n sets, Cartesian product of the n set, there are n tuples. Means for 4 set it is the 4 tuple. For the 3 set it is called triplets. Now students, one important note is here that if R is the set of all real number, then R cross R represent the whole coordinate plane, which is the set of all the points lying in the plane. And similarly, R cross R, it is the R cube. It represents set of all the points in the three-dimensional space. Now students, most important topic, the number of elements in the Cartesian product. Here is a formula. The number of elements, or you can say cardinal number in the A cross B, it will be equal to NA cross NB. Means if there are 4 elements like A, B, C, D and B is equivalent to A, what is the meaning of equivalent set? The meaning of equivalent set is that the set B also contains the 4 elements. Then the number of elements in A cross B will be NA into NB, that is 4 into 4 will be 16. And in this case, B cross B is also equal to NB into NB, and it will be 4 into 4, 16. If let there is a set A containing 3 elements like this and set B containing only 2 elements like A, B, then number of elements in A cross B will be NA cross, or you can say multiply NB, and it will be 3 into 2 equals to 6. Students, let's see an example here. Let A and B the two sets such that NA equals to 3 and NB equals to 2. And if x, 1, y, 2 and z, 1 are in the A cross B, then you have to find A and B. Means A cross B contains the elements like x, 1, y, 2 and z, 1. As we know, first elements come from set A and second elements come from set B. Means you can write set A like x, y, z. As we know n equals to 3, then it is over. Then for set B, the set B is second element, means it is the 1, 2 and the number of elements are 2, then it is okay. Now the set A is here and set B is here. Students, let's see an example here. Cartesian product A cross A has 9 elements, among which 2 elements are given, means A cross A contains 9 elements. What is the meaning of this? Means NA into NA equals to 9, because set is same, that's why there are 3 elements and 3 elements here. 3 into 3, 9. Now A cross A is given. It is minus 1, 0 and 0, 1. There are only 2 elements of A cross A. As we know, the first elements come from the set A, means A contains minus 1, 0 and 1 also, because second element is also live from the set A. Yes or no? That's why, what is the set A? Set A is minus 1, 0, 1. Okay. Thus, we find the remaining elements of A cross A. How? It is the A is minus 1, 0, 1 and again A, it is minus 1, 0 and 1. Now A cross A will be minus 1, minus 1, minus 1, 0, minus 1, 1, 0, minus 1, 0, 1 and this is okay. Now 1, minus 1 and 1, 0 and 1, 1. Remaining elements of A cross A are here. Students, now we are going to study representation of Cartesian product of the two sets. How to represent the Cartesian product of the two sets by different methods. First method you can say arrow diagram method. Let A the set 1, 2, 3 and the B A, B. Then what will be the Cartesian product of set A and set B? It will be 1, A, 1, B, 2, A, 2, B, 3, A and 3, B. The arrow diagram representation is here, and this is the method to represent Cartesian product of two sets by arrow diagram method. Students, let's see an example here. Set A is here, set B is here. Represent the following product by arrow diagram methods, means A cross B here. Let set A like this and elements 1, 2, 3 here, and set B 5, 7. Then you can represent like this: 1, 5, 1, 7, 2, 5, 2, 7 and 3, 5, 3, 7. Now how we can represent B cross B? B cross B can be represented as, here is the set B and set B, 5, 7, 5, 7, 5 and to 7, 7 to 5 and 7 to 7. This is the representation. Now one more representation, graphical representation of Cartesian product of two sets, means that there are the numbers, or you can say set 1, 2, 3 and 2, 4. Ordered pair can be represented as a point, just like a point, means 1, 2 is here, 2, 2 is here. Okay. Students, let's see one more example. Let A equals to minus 1, 3, 4 and B is here. Represent the following product graphically by the lattice. This is called the lattice representation also. Now you have to take y-axis and x-axis like this, and here is the 1, 3 and 4. Here is minus 1 here also, and here is 1 and 2. Okay, now first point, or you can say first ordered pair will be minus 1 comma 1, that is here, you can like, then minus 1 comma 2 is here. Okay, then 3 comma 1, 3 comma 1 is here, and 3 comma 2 is here, and 4 comma 1 is here, you can say, and 4 comma 2 is here. Similarly, A cross A can be represented as this is the x-axis and this is y-axis. It is minus 1, it is the, you can say like this 3, or you can say 1, 2, 3, then it will be 3, and it is 4. Okay, now in this axis it is 1, 2, 3, 4, and here is the minus 1, minus 2, minus 3, minus 4. Then A cross A is minus 1, minus 1. Where is the minus 1, minus 1? It is here. Minus 1, minus 1 is here because we are going to find A cross A. We can write down here A is equals to minus 1, 3, 4, and A is equals to minus 1, 3, 4. Means minus 1, minus 1, minus 1, 3. Minus 1, 3 is here, like, and minus 1, 4 is here. Then 3, comma minus 1, 3 is here, and minus 1 is here. And 3, 3 is here. And 3, comma 4, 3, comma 4 is here. Now 4 comma minus 1, 4 comma minus 1 is here, 4 comma 3 is here, and 4 comma 4 is here. This is the representation of Cartesian product by lattice. Students, now it is time to understand the relation. Why did we study the Cartesian product of the sets? Ordered pair of set. It is because of relations. Because relation is the subset of A cross B. This is the basic definition of the relation, which is defined from set A to set B. If a relation is defined from set A to set B, then it is necessary that each will be a subset of A cross B, which is the Cartesian product of two sets. Students, let's see this example. Let set A contains 1, 2, 4 and set B contains 4, 6, and relation is given here. This relation is defined from set A to set B if the relation is subset of A cross B. Now let's check A cross B. What is the A cross B? The A cross B is from set A to set B. It is defined. First elements come from set A and second from set B. It is 1, 4, 1, 6, 2, 4, 2, 6, 4, 4, 4, 6. This relation will be a relation from set A to set B if the elements of the relation are the elements of A cross B. Now check it. Now it is okay. This is here and this is here. That's why the relation is the subset of A cross B. Therefore, we can say the relation is defined from set A to set B, or you can say R is a relation from A to B. Students, let's see another example. Here A is 1, 2, 3 and B is 2, 3, 5, 7, and relation is given here. But you can observe that this is not a relation, or you can say not a defined relation from set A to set B, because the relation is not the subset of A cross B. What is the meaning of notation of elements? In this example, if we can say 1, 4, belongs to R, then we can write it like 1R4, or you can say that 1 is related to 4 with the relation R, and this is the notation of elements, and it is given here. If A comma B belongs to R is also written as ARB and read as A is R related to B. Students, let's see a question here. Find the relation R from set A to set B defined by x is less than y. As we know, the relation is the subset of A cross B, and relation is defined here, means you can write relation, it is 1, 2, 1, 4, 2, 4, 3, 4 only, and it is the subset of A cross B, because as we know, when we make the A cross B, then these elements comes in A cross B. Students, now it is the time to understand the basic concept of domain and range of a relation. Now, what is the domain and range of a relation? It is a most important topic. A relation is defined from a set A to set B. Then relation is given in the form of ordered pair, because relation is the subset of A cross B. If it is given that a set A given that set B, and relation is defined like this, A comma B, such that A belongs to A and B belongs to B, then all the first element of ordered pair will be the domain of the relation. Students, it is mentioned here, let R be a relation from set A to set B. The domain of relation R is the set of all those elements A belongs to A, such that A comma B belongs to R. For some B belongs to B. The domain of R is precisely written as dom_R. Thus, the dom_R is the set of A belongs to A, such that A comma B belongs to R. For some B belongs to R. Domain of R is equals to set of first components of all the ordered pair belonging to the relation. Now, what is the range? Range of a relation, let R be a relation from set A to set B. The range of R is the set of all those elements B belongs to B, such that A comma B belongs to R. For some A belongs to A. Thus, the range of R is the element B belongs to B, such that A comma B belongs to R. For some A belongs to A. Range of R equals to set of second components of all the ordered pair belonging to the relation. What is the codomain of a relation? If relation is defined from set A to set B, then whole set B is called the codomain. Range is the subset of codomain. Let it is the A given 1, 2, 3, and it is the B, set B given let 2, 3, 4, suppose, and the relation is given like this 1, 2, and 2, 3. Got it? Then what will be the domain of the relation? Dom_R, or you can say domain of the relation, is 1, 2, and range of the relation you can see 2, 3. And what is the codomain? Codomain is the whole set B, and as we see here, codomain and range is here, and range is the subset of codomain always. Students, let's see one more example. Set A is given here, relation is defined from set A such that A comma B, A divides B, then find the domain and range. If A divides B, then what is the relation? Relation will be 1, 1, 1, 2, 1, 3, 1, 4 and 1 comma 6. Now 2 comma 4, 2 comma 6. This is the relation. Then what is the domain? Domain of relation is first elements, means 1 and 2 only. And what is the range? Range of the relation will be second elements. What is the second elements? 1, 2, 3, 4 and 6. This is the domain and range of the relation. Students, so far we have studied about basic concept of relation, their domain and range. In next video lecture, we will study remaining concept of this chapter, relation and function.